Welcome, everyone. Today, we are going to explore the fascinating world of airplanes and how they are able to fly. Have you ever looked up at the sky and wondered how something so heavy could stay airborne? Well, you're not alone. In this presentation, we will delve into the science of flight and uncover the secrets behind airplane flight. We will examine the basic principles of flight, the role of different parts of an airplane in flight, and the instruments used to navigate and monitor flight. So, fasten your seatbelts and get ready for an exciting journey as we explore the wonders of flight. One of the most important principles involved in airplane flight is Bernoulli's principle. Bernoulli's principle is named after the Swiss mathematician Daniel Bernoulli, who discovered that as the speed of a fluid increases, its pressure decreases. This principle is what allows airplane wings to create lift. The curved shape of an airplane wing causes the air flowing over the top of the wing to travel faster than the air flowing underneath it. As a result, there is an area of lower pressure on the top of the wing and higher pressure on the bottom. This pressure difference generates lift, which is what allows the airplane to stay in the air. Interestingly, Bernoulli's principle also explains how a curveball in baseball works. When a pitcher throws a curveball, the ball is spinning, which causes the air flowing over one side of the ball to move faster than the air flowing over the other side. This creates a pressure difference that causes the ball to curve in flight. So, Bernoulli's. Let's talk about airplane wings. Airplane wings are not just simple flat surfaces, but are carefully designed to create lift, which is what allows the airplane to stay in the air. The shape of an airplane wing is called an airfoil, which has a curved shape on the top and a flatter shape on the bottom. The angle at which the wing is tilted upwards, called the angle of attack, affects how much lift is generated. A greater angle of attack means more lift, but if the angle is too high, it can cause the airplane to stall and lose lift. Flaps on the trailing edge of the wing can be extended to increase lift at lower speeds, such as during takeoff and landing. Winglets at the tips of the wings reduce drag and improve fuel efficiency by reducing the vortices that form at the wingtips. In summary, airplane wings are not only designed for aerodynamic efficiency but are also engineered to provide lift and stability to the aircraft. They are a critical component of the airplane, and without them. Now, let's talk about thrust. Thrust is the force that propels an airplane forward through the air. Most airplanes use jet engines to provide thrust. Jet engines work by sucking in air and compressing it before igniting fuel to create a high-speed exhaust that propels the plane forward. The amount of thrust needed depends on the weight of the airplane and the speed at which it needs to travel. Some airplanes use propellers or rockets for thrust. Propeller-driven planes work by converting the rotational energy of the propeller blades into thrust. Rockets work by expelling exhaust gases out the back of the rocket at high speed, creating a forward thrust. Without sufficient thrust, an airplane would not be able to take off or maintain altitude. So, it is an essential component of flight and something that pilots and engineers pay close attention to when designing and operating airplanes. Next, we have drag, which is the force of air resistance that opposes the motion of an airplane. Airplanes are designed with streamlined shapes and smooth surfaces to minimize drag and make them more efficient. There are two types of drag: parasite drag and induced drag. Parasite drag is caused by the airplane's shape and can be reduced by using smooth surfaces and covering exposed parts of the airplane, such as landing gear, when not in use. Induced drag is caused by the creation of lift and cannot be eliminated completely. However, winglets and other aerodynamic improvements can reduce induced drag. Reducing drag is important for airplanes because it helps them fly more efficiently, which means they use less fuel and can travel longer distances. So, designers and engineers always look for ways to minimize drag and improve an airplane's aerodynamics. Moving on to slide 6, we have control surfaces, which are used to control the direction and stability of an airplane in flight. There are three main control surfaces: the rudder, the elevators, and the ailerons. The rudder is located on the vertical tail fin and is used to control yaw, which is side-to-side movement. The elevators are located on the horizontal tail and are used to control pitch, which is a pan-down movement. The ailerons are located on the trailing edge of the wing and are used to control roll, which is tilting from side to side. Flaps can also be extended to increase lift and drag during takeoff and landing. These control surfaces are controlled by the pilot through the use of a joystick, pedals, and other controls in the cockpit. The ability to control an airplane in flight is crucial for its safety and efficiency, and these control surfaces play a vital role in ensuring a smooth and controlled flight. The center of gravity is the balance point of an airplane and plays an important role in the airplane's stability and handling. The pilot must ensure that the airplane is loaded correctly to maintain the correct balance and center of gravity. If the center of gravity is too far forward or too far back, it can lead to instability and make the airplane difficult to control. Ballast, which is extra weight, can be added or removed to adjust the center of gravity if necessary. Flight instruments are an essential part of any airplane's cockpit, providing pilots with critical information about the airplane's performance and position in the sky. There are several types of flight instruments, including the airspeed indicator, altimeter, attitude indicator, heading indicator, turn coordinator, magnetic compass, and GPS. These instruments help pilots maintain the correct altitude, speed, direction, and level flight, as well as navigate to their destination. They are especially important during takeoff, landing, and in poor weather conditions. Pilots must be skilled at interpreting and using these instruments to ensure safe and efficient flight. During takeoff, the airplane needs to gain enough speed to generate lift and become airborne. The pilot uses the throttle to increase engine power and the elevators to raise the nose of the airplane. Once the airplane is airborne, the flaps are retracted to reduce drag and increase speed. During landing, the pilot uses flaps and the throttle to slow the airplane down and descend gradually. The landing gear is lowered, and the pilot uses the elevators to control the angle of descent. The goal is to make a smooth landing, with the airplane touching down gently and coming to a stop on the runway. Takeoff and landing are two of the most critical phases of flight, and pilots must be highly trained and skilled to perform them safely and successfully. That concludes our presentation on how airplanes fly. We have learned that the science of flight is based on the principles of Bernoulli and airplane wing design, which generate lift. Thrust provides the force to propel the airplane forward, and control surfaces are used to maintain stability and control. Pilots rely on flight instruments and techniques to safely navigate and control the airplane during takeoff, landing, and in flight. Air travel has transformed the way we travel and connect with the world, making it faster and easier to reach far-off destinations. Thank you for joining us today, and we hope you have enjoyed learning about the science of flight. Hi, I just wanted to take a moment to say thank you for watching my videos and supporting my channel. Your comments, likes, and shares mean the world to me and inspire me to keep creating content. If you haven't already, please consider subscribing to my channel. By doing so, you'll never miss a video and you'll be helping me reach more people with my message. I promise to continue providing high-quality and engaging content that you love, so hit that subscribe button and join our community today. Thanks again for your support, and I will see you in the next video.